Okay, we're going to continue to use the washer method. So remember, we're finding the volume when it's being revolved around a line, and it's a particular region that we're revolving it around. And many times when we do the vertical slicing, if it's revolved around a horizontal line like the x-axis or y is equal to b, we tend to see a washer. Okay, so not all the time do we see a washer, but it looks something like this. And you can draw a washer anywhere between the function and the line you're revolving it around. Okay, unless it's a different shape, but we're still sticking with washers for now. And it creates this three-dimensional object. And you can see like I kind of stacked up like different washers. So you can see it does become maybe something that can hold water, or maybe not water unless the bottom's sealed. But let me give you another for instance. Okay, so here's something, a vase, or for some people they call it a vase. You can obviously see how if I did cut it, it would be a horizontal cut instead of a vertical slicing, but it definitely would be a washer no matter where I kind of like cut through it, if I could possibly cut through glass. So pretend I am a superhero and I can somehow do that because it's a superpower. So we're still revolving it around a line like the x-axis, like y equals equal to b. So it is more of a vertical slicing. Ta-da! I couldn't hold it together and kind of show you what it was when it is that vertical slicing, but you can see all the discs. Anywhere you can draw a disc between the function or the region revolving around our line. So that actually gets you a little bit more used to what a cross section is. This washer is a cross section when you do a vertical slicing or a horizontal slicing, which we'll get into our next lesson. So just making sure we understand how to do our washer method when everything's revolves around something like the x-axis, the y equals b equation. Everything's in terms of x. So we're going to do another example, and if you really understand these examples, then when I kind of do the vice versa on our next lesson, you'll know what to do. Okay, so take a minute to get this down. So we're finding the volume of a solid generated when the region, so we're going to picture a region, it's being revolved around. It's creating a three-dimensional object, therefore we could find the volume of it. And it's bounded by these functions. Okay, and so these functions could be bounded together somehow in some quadrants in the coordinate plane, or maybe more than one quadrant, depending on the problem. And it's rotated about a line. So in this particular case, our line is y equals -2. So here we go. I'm going to start off, make sure you get down this important information before we start the problem. So we're starting off with our coordinate plane. And being that I did this problem before, there's a reason why my third and fourth quadrants are much bigger than my first and second. Think about it when it says the line is y equals -2, where that's going to fall. Okay, so that is below the x-axis. And that's why I kind of made that larger. Let me continue to draw this out. Please do the same thing in your notebooks. I missed the negative sign there. Okay. I don't know why my numbers are getting bigger. So here we go. We start to plot some points, and if we plot y equals x squared, okay, I'm just kind of plotting it here. You can plot it over here. I'm going to add the -1 if you like. So we have a curve that looks something like this. It's not exactly 1, 1, but you can imagine it there. And if you were to plug in points for y equals x cubed, okay, some of these points are the same, but if let's say you plugged in 1/2 into our first function, okay, we'd end up getting 1/4. But if we plug it into our second function, we get 1/8, which is much, much smaller. So be careful when you're kind of drawing out that function and what values like you're using. So you can see that there's a region here. I'm going to draw that in. We're going to revolve around. And we're revolving it around the line y equals -2, which is down here. Sorry, it looks like a curve. It should be a line. And let me label this just so you know. Okay. So there's a lot of space in between this, okay? So definitely take a look at the spacing on this particular problem. So when we revolve it around and it comes onto the other side, we're going to see it go down, well, let's see, it goes down 2 units towards y equals -2. So it's got to go down another 2 units. So there's a point here and there's a point here. And this part's connected by a curve. It's a little bit more like a straight line. And then we have another curve, same 2 points, but it's going to go this way. So it should, your region that you shaded, I used the color black to shade it, when it comes down, it should kind of transpose like this. So draw on your washer, and your washer could be anywhere from in your region, okay? And you can definitely see how it's a washer from beginning to end because you have this big space. So I'm trying to draw. So that's the outer circle and inner circle. And it's not such a very good inner circle. The inner circle should be touching from the bottom of your region to the top here, and I kind of messed that up. Let me see if I can erase that. Okay, I think this washer is a little bit better. So the top of the bigger circle is going to the top function, to the reflected bottom function, and the inner circle is going from the bottom function towards the top of the reflected region. And so that's helpful when we have to decide on how to measure our radius. So let's talk about that. We have big R and small r. And these are of x because we're revolving it around a line that is similar to the x-axis is y equals b. So tomorrow it's not going to be functions of x. You can guess it. Tomorrow will be functions of y. Okay, so our original functions are up here where we shaded in our region, okay? So let's start with the smaller radius, so I could kind of draw that in here. And you can see how it's touching y equals x cubed and it's going down to y equals -2. So remember when we do around the x-axis or lines that are y equals b, okay, our radiuses are functions of x. You have to do top minus bottom. So it could take a wild guess for tomorrow that we're going to do right minus left. Okay, but now we're going to do top minus bottom. Okay, for our smaller radius and for our bigger one, which I'm going to try to emphasize here. And our top minus bottom would be top minus bottom. There we go. Okay, And so as we take a look at this, we can also simplify it. You don't have to right now. You can do that in your expression to find the volume of the solid generated when revolving the region about the line y equals -2. Okay, we're going to take out the pi, and we're going to use x values here. So our region started when x was 0 to when x is 1. We're going to have big R squared, and big R turns out to be x squared plus 2 minus little r squared, okay, which turns out to be x cubed plus 2, and it's going to be with respect to x. And so this is our setup, and we can solve. All right, so take a look, make sure you understand it, and we're going to start solving. Okay, so also take a moment to get it down if you didn't get it down already. Okay, so our volume is pi times the integral from 0 to 1 of the expression x to the 4th plus 4x squared plus 4, and we're subtracting the quantity x to 6 plus 4x cubed plus 4. My 4s are weird. And we're doing this with respect to x. So we just have to simplify our expression so that we can integrate this. This will become x to the 4th plus 4x squared minus x to 6 minus 4x cubed with respect to x. So a little bit neater on my 4s, but not so much on my 6. That was a 6 there. So when we integrate, we're going to be using x to the 5th over 5 plus 4x cubed over 3 minus x to the 7th over 7 minus x to the 4th. We're going to plug in 1 and 0 respectively. So we plug in our 1. And as you plug it in, you can start to calculate what this would be. See if you can make a common denominator. If not, you're going to have to write that out. This is a 7, by the way. And I have a need for another bracket here, although this is all going to be 0. Yep, even the last term. So not too bad. So volume's going to be pi times 3 over 15 plus 20 over 15 minus 8 over 7. I'm going to make a common denominator again. So our common denominator is going to be 15 times 7, which is 105. And this is going to be 41 times pi, so this is going to be our final answer. And we're all done. Okay, so do some of the practice problems. Let me know if you have any questions. Good luck.